So with that, Kelly, I'm going to turn it over to you and Conrad. Kelly will go first. This month's deep dive in the skill gap with smart manufacturing. And Kelly here is one that will really show you where Raytheon is and what their challenges are and their path to the future. So Kelly, I think you have control.
I got some slides I'll go through that gives our perspective, both mine from Raytheon Intelligence and Space, and as well as a little bit broader corporate view. I want to recognize the contributors of the presentation there on the right, Aaron Demonskis, who's on this call, Nathaniel Tyndall and Meredith from the first two from our corporate Industry 4.0 organization, and Meredith from our sister division, Raytheon Missiles and Defense. So I'm our Advanced Manufacturing Tech Director in Raytheon Intelligence and Space, which is one of the 4 business units in the new Raytheon Technologies. And I won't spend much going through the company, but just a real quick overview so you know who we are if you're not familiar. Raytheon merged with UTC last year, and we have 4 business units that were created out of that. Collins Aerospace, Pratt & Whitney, Raytheon Intelligence and Space, where I hail from, and Raytheon Missiles and Defense. So UTC spun off a couple divisions, and Raytheon consolidated from 4 businesses to 2, and there's some minor spin-offs within that as well. So that's the new Raytheon Technologies. We're, in general, got a slide on some of the capabilities. I'm not going to go into the details, but in general, we play pretty much everywhere in the aerospace and defense sector, with the exception of airframing and building ships. I mean, those are kind of the 2 big things we don't specifically do, but we put sensors and products all over ships, planes, ground vehicles, space, et cetera, et cetera. So, we play in all those spaces. We also do a lot of the mission planning, mission architectures that define what platforms you even need to execute those missions or meet a customer demand in the commercial aerospace business. So that's all I'm going to talk about Raytheon Technologies for now. So I have a couple setting the stage kind of philosophy slides that I'll walk through. And one way that I think about this when we look at our journey, at least the journey I've been on for the last almost decade here, is often we tend to think about when we get into these philosophical discussions about digital transformation and digital technologies being basically the people that create the technology, the actual technology, and then the users. Kind of simplistically, but when you really get into it and start doing smart manufacturing, digital transformation, there's a far more rich ecosystem that's required. It's not just some technologists and upskilling the folks that are using the technology. You think about the phone and what got created when you start moving from the cell phone, an analog phone, or even a digital push button phone into cell technology, and then into the smartphone realm. It's a whole ecosystem, software development, cybersecurity, the hardware supply chain, systems design, which is to me one of a really huge factor in smart manufacturing, is that systems architecture and design, data analytics, analysis, repair service. I mean, go down the line, right? It's a very rich ecosystem. So that workforce development is really not a simplistic thing. You gotta kind of think across all those different aspects. And then of course we gotta focus on the support of the end user. So when we dig down a little deeper into manufacturing specific, again, somewhat philosophical, but I think it's really important for us to set the stage, since we are talking smart, which is the technology piece, manufacturing, which has gone through 3 industrial revolutions and on its 4th. We need to keep in mind some of our traditional, lean manufacturing philosophies, and one of those is that the intent of what we do in manufacturing is to keep the operator, the human, if there's a human in the loop, building and efficient, right? If there's not a human in the loop, there's a human somewhere in the loop, potentially as a frontline leader or a technician, or even a plant manager, right? We need those humans to stay at the center of all of our technology development. But just thinking, we do a lot of assembly and integration in Raytheon Intelligence and Space, and some of the personal experiences we've had in developing automation, both digital and physical, and deploying those and interfacing with those humans, are some of these things you see on the left. Getting used to working with digital work instructions that may have models that you can spin. It's not a piece of paper and a picture. You can digitally poke-yoke processes, error-proof those processes, and it's not super fun. I mean, even when you're on your computer, right, and your computer pops up the screen and says, you can't do that, and you kind of have that guttural reaction, like, why not? I've been doing that for, the last 10 years. So you have to get used to some of those interfaces. Interacting with robotics and cobotics, which the robotics is pretty well defined. Cobotics, I think, is still emerging, at least in our space. You still have to have that core traditional assembly and processes skill set. You can't lose that, so we're really adding to the knowledge base. And then, at the end of the day, like I said, is keeping the human experience and productivity central to what we do in Industry 4. So this slide gets a little more into the technologist side. I presented this at the 2020 conference for System Engineering Research. I called it, tongue-in-cheek, the dearth of the unicorns. When I think about a chief engineer under me that's looking across our Industry 4 realm, which includes digital and physical automation, you start getting a pretty unique collection of skill sets. You can see there in the middle. And we started off really kind of more just adapting manufacturing engineers to learn automation and some of the digital technologies. I think where we're at today and where we're continuing to evolve to is this collection of skill sets. So my chief engineer, I'm looking for folks that have some background in system engineering and architecture to look at the software systems and the integration with the physical robotics. They need to have some background in manufacturing engineering and working on the floor, how traditional manufacturing works. They have to have some background in software development, so working with our software teams. And then on down the line, mechanical, new product introduction, transitioning products into production from development, data science, and then of course some element of the product technology knowledge, which is a pretty substantial part of what we do. And then lastly, before we get into some more specifics, one of the things that Raytheon's been doing, we're essentially a mega aerospace and defense corporation now, is to have some level of an operating system that helps the businesses work in a common way. This may not be applicable to a single site small business, but once you start scaling to multiple sites, really after you hit 2, you need to start having a common language and a common way of doing business. And so that's an important part as we develop Raytheon Technologies and this core operating system in order to help us evolve that at the same time with Industry 4, so they're working in synergy. These include things like key process indicators, KPIs, goal alignment. We call it control towers. So you have multiple KPIs in certain categories you can look at across different businesses and factories. And all the way down to some of the basics of how you run your factory from a lean perspective and visual management, 5S, Gemba, Kaizen, et cetera. So where we're at today, we are, we're really working together across the businesses. Erin's one of my partners. All right, I should say I'm one of her partners, and she helps pull a lot of this together. But looking at key roles and skill sets, what our internal gaps are, what's that central competency model when we look across smart manufacturing and automation, and that's somewhere where we really look forward to engaging with CESMII on. We have already through our workforce development, industrial advisory boards, and looking forward to those projects and the output of CESMII so that we can fold those into what we do as a business. Because again, these are some of those common things that I think CESMII helps pull together from a broad skill set base and the membership so that we can all benefit from it. And I do list a couple of the skill sets, or we do up on the upper right, just some examples of needed skills, and I'll have a couple more examples on another page. looking at those smart interfaces, programming, familiarity with OPC, we kind of go down the line there. One more resource that, and these slides are distributable, so they've been approved. There's a great article in Smart Manufacturing written by one of our partners in Raytheon Missiles and Defense, Brian Murphy, talking about what those learning models look like, and now in COVID, how we've been able to experiment with some blended learning models, some online, some have to be in person, a lot of interactivity, and then touching on some key elements like decision making, which is not a technology skill set, and using some real life scenarios to help people really learn. So it's a good article. I'd refer you to Smart Manufacturing Magazine there. It's all publicly available. So a few of the competencies we're looking at within our INS and to some extent across the corporation at different levels. Really, again, starting with some of those foundations, right? If you're doing manufacturing, you have to have some understanding of lean, Kaizen, some of those principles that have been in place for a long time. So you don't automate waste, and you know how to identify as a smart manufacturing practitioner if you're being asked to automate waste, and when you can push back and say you need to lean out your value stream before we go do that. Where should I be taking data to support some of my lean practices? And then in the smart manufacturing realm, the smart realm really are some of those key skill sets. Some of the ones that we've had a significant challenge around is, how do you write robust system engineering requirements when you're working, especially with outside integrators, but also for your internal software development teams. Once you start to scale that, it gets to the point where you can't just have one or two smart people that can translate between what the user wants on the floor, management or an operator, and how that software gets developed. You need to have some systematic processes to be able to capture that, translate that into software development. We're looking at model-based architectures and systems. So when you look at the tools that are out there to define product systems, you think about model-based system engineering and in particular and requirements development. How do those play into how we document our technical data packages for our smart manufacturing systems? Some basics like robotic certification and safety, that's absolutely critical. Core value for Raytheon, of course. Geometric dimensioning and tolerancing, which we've seen a pretty significant gap, particularly I'd say in the supply base for some of the automation systems we've seen. PLC programming, software control system theory. Some of the management techniques and planning techniques like DevOps and scaled agile framework, which basically allow you to scale agile techniques and software development techniques that most of the software product industry is incorporated. Be able to harness those, because hardware development waterfall schedules doesn't make sense when you're talking software. And then at the technician level, right, having some very skilled technicians that are able to work on automation systems that are not just assembly operators putting parts together. I think I only have 2 slides left, if I recall. Again, one of the reasons we participate with CESMII and engage across the board, and this is a personal passion of mine, is that we really need a robust pipeline, and not just engaging with a school here and there. We need to be thinking all the way from high school all the way up through professional development. I give some examples of where we've engaged down below. We engage with our community colleges. Collins is out in Texas, one of our large sites. We used to do engineering games pre-COVID on site at Raytheon, where we get 100 high school students together and immerse them in STEM activities and challenges, hands-on. Lots of university connections, of course. The National Science Foundation, a lot of the grants that they've provided to the universities, as well as students. I know there's, Jim Davis has been instrumental in a lot of the NSF work, and we try to engage in that as much as we can also. The consortiums you're familiar with, Society of Manufacturing Engineers, Industrial Engineering, and then, of course, the Manufacturing USA Center. So in my mind, that ecosystem is absolutely critical to U.S. competitiveness writ large in industry, but also in our industry and in national defense for Raytheon Intelligence and Space. Some interesting statistics over there from the Bureau of Labor Standards and Statistics. You know, the demand for industrial engineers relative to regular engineers, I thought was pretty substantial. So I might have to go back and get another degree. Hopefully that kind of sets some of the stage, gives you some background on the way we're thinking. In summary, you know, we're certainly invested in our manufacturing, smart manufacturing Industry 4 journey. The fact that Aaron works for an organization called Industry 4.0 in corporate, I think speaks volumes. You know, requires a convergence of skill sets that have not previously been in place, but also combined with a decades-old, you know, traditional manufacturing, tried and true lean and regular manufacturing techniques. You know, multimodality methods of delivery and engagement. It's going to take you know, some new thinking on how we deliver that training. We talked about the smart manufacturing ecosystem and how critical that is to our economic and national defense. And then you know, having an organic pipeline of manufacturing talent using our whole innovation system of education across the U.S. So I think with that, I will get off the stage and pass the baton over to Conrad.
But Kelly, it's been an honor to have known you for the 4.5 years, and thanks for providing a perfect use case of how Raytheon has taken this serious and how you and your team have spearheaded it for Raytheon. So thank you, sir.
And thanks for holding your questions, but we will tackle them right after my short presentation. What I want to do is Kelly talked about the need for new competency models and new smart manufacturing skills in the workforce. And I want to talk about what is CESMII, how is CESMII contributing to that? And by the way, those thoughts are very aligned, Kelly, with the thoughts that we have here, the whole team here. I know your team is part of the team collaborating here of educators, but I just want to echo that if you look at that presentation that Roy was talking about earlier that we posted in the newsletter, you'll see that we're very aligned in terms of those skill requirements. I want to first remind everyone that smart manufacturing education is one of the 4 CESMII strategic pillars. We're drilling down on education today, but keep in mind during my presentation of what we're doing that all these 4 quadrants are very linked together. I've put this slide together to try to summarize some of the education initiatives that we have going on. But in the main key message here, your takeaway should be that we depend on our ecosystem to both develop education and deliver education. There might be a few offerings of education that come directly from CESMII, but by far the biggest impact on workforce education is going to come from ecosystem partners. So the theme here is resources built by members, for members, and for the greater ecosystem. And at the center of that, the repository of educational resource is a key part of our strategy. And I will also talk about our education catalog is really the way that our ecosystem partners are delivering and creating impact at national scale. Let's start with drilling down on some of the resources that you all have availability to. And we've been talking about the knowledge portal as the place to get started where we share information. We have over 300 members that have onboarded to the CESMII knowledge portal. And remember that each one of your companies can onboard and give access to more people, and we encourage that, to more of your employees to the knowledge here that we're providing at CESMII, so you can then take it back and embed it into your own educational programs. So it's not only a place to share educational content, but it's a place to explore about our technology and our ecosystems, including the pages on the innovation centers and affinity groups. But we do have the full educational catalog there of the knowledge catalog of Sesame resources available. And it's always up to date. That includes articles, papers, videos. And I hope all of you by now have access and have been browsing around, and we want to hear your feedback. We have, for example, organized all our knowledge sharing webcast series. And each one of those has metadata there. So really take advantage of the search capability, the text search capability, and just type the keywords and you'll be presented with all the pages that have information on that topic across the whole knowledge base. Another tool that we're developing is a tool set for manufacturing transformation. And it's basically designed to accelerate adoption. We're focusing on small and medium manufacturers as the target audience for this, but it's a tool set of assessment tools, roadmap, the building tools, and justification tools. Because education is not just for the workforce bottom up, it's really top down, right? So we need to make sure we're educating the champions and helping them justify these initiatives to their management. And we're along with these tools, we're going to have a network of consultants trained to help small, medium manufacturers get started on their journey. There are 6 areas we're looking in the framework for this assessment, and that includes strategy, culture, supply chain, systems, processes, and workforce. We're still developing this framework, but I'll give you a little teaser here. Well, basically, we're creating a framework in the 6 dimensions of what it means to be at level 1, 2, 3, 4, 5, all the way to a very mature smart manufacturing practice. The 5 is probably going to be a goal where only the very, very leaders and even not a whole company might be at, but maybe some divisions within a company. So but more to come on that. We're looking to run this as one of our workshops at the annual conference. Just another reason to attend our annual conference in person. This will be part of the training we're going to make available there. And it's targeted to be available by December. But another great educational resource is that we have curriculum resources that are being developed through the RFP projects. So the RFP projects are not only creating fully functional curriculum that our partners are delivering to the ecosystem in the catalog, but they're also sharing resources, the PowerPoints, videos, tools, data sets. A lot are available in the repository, and that's already some of the RFP1 projects have already delivered into that repository. So if you are interested in leveraging the resources, also become part of this education ecosystem. We appreciate the team of collaborators we have here at CESMII. I'm honored to work with them, and they all share this common vision to share and democratize the knowledge. This is an example of the skills that we're looking for, the scope of skills for smart manufacturing, all the way from learning the fundamentals to learning about data capturing, about information modeling, about visualization, about human machine interaction, about process modeling, about the use of AI and machine learning, complex problem solving, and not just within the factory, but also the factory as a node in a supply chain. So all of these are areas that we're looking for. And in terms of the occupations that we're trying to upskill, there'll be different depth and maybe a different perspective into some of these skills. but you get a feeling of the occupations there. And this is part of what the education committee keeps evolving and working towards. We've had 3 project waves. The one just starting now, RFP2 has 4 great projects, and I show you here to give you a feeling of the caliber of the partners working with us from Purdue to Festo, West Virginia, University of Texas, El Paso to Auburn. We got great partners working with us towards the smart manufacturing curriculum development, and they're part of this ecosystem that is sharing their knowledge. So it's a great team. Part of the resources also that we want to make available are hands-on resources for hands-on education and training. We believe that's a very important part of the smart manufacturing skills and competency. And we know that manufacturers are looking for candidates with experience with industrial tools and software, so that when they go to their sites, they're ready to go. So we have a few projects towards that end. Not only do we have all the innovation centers that are coming online with the new wave, but in each one equipped with industrial assets integrated to the platform and great demonstration platforms. But we're also have an RFP3 out there that is requesting projects for simulators, digital twin projects that are data sources that we pump through the platform and could be then produce data that is consumed by educational applications for visualization, machine learning, different types of exercises. We want that package, not just the technology, but the exercises for the students and all those dimensions. And all of this stuff, we want it all to relate together. So from the hardware kits we're putting together, these under 5K hardware kits to these virtual reality systems and simulators, all going through the platform towards that curriculum for those development of those skills. So I want you to look at this as a full connected set of resources that we are trying to make available to this ecosystem. And we're trying to do it at a level that is appealing to community colleges or even manufacturers to bring into their companies, because they're affordable and practical solutions that can be deployed even with small manufacturers. So the last thing I want to talk about is our education catalog. We just put a link on the website for that. You can look for it under education, and you get here a sampling of the partners that we have that are helping us deliver education. So what we're doing is whether it's a program that's been developed through one of the projects or another partner working with Sesame, we're reviewing education, making sure giving it a Sesame endorsed label if it has all of those principles and concepts that we want to see in smart manufacturing education, that is up to date, that we're not just grabbing an old PLC class and calling that smart manufacturing. I mean, nothing wrong with PLC skills. All those skills are needed. There's a lot of foundational skills, but we're focusing on filling the gaps in the smart manufacturing curriculum and making sure that we're all upgrading curriculum with the latest skills required. So that is part of what we're doing. I can click here as an example on the Penn State program, and you can scroll through it, but you'll see it's a great example of how they're leveraging the Sesame endorsed label and how they are and the kinds of skills that they're bringing to the market. And we're very proud of these partnerships. We have great partnerships. We have just a few partners now, but I'm hoping to double this list by the end of the year and continue to expand it. So that's really what I have for today. And now we could go into questions and answers. Questions for Kelly or for myself, either are welcome, please.
Yeah, to echo that, Conrad, thanks for presenting what you did for what we have to offer from your program. You know, we still have a few more slides to go over on some project updates and other items, but we wanted to leave enough time if anybody had any questions now to ask Kelly or Conrad.
Hi, Dale. This is GP. I would like to ask Kelly a questions.
Sure, GP.
Kelly, thank you very much for outstanding presentation. As pointed out, this is really a multidisciplinary focus, taking holistic way for smart manufacturing system engineering work, requiring students from very, very different, diverse background. So what is your view of doing the team teaching type of a project so that students from different disciplines can participate? And in that way, they can do peer-to-peer learning and sharing their experience as a way to really cultivate this a new generation of learning. What is your opinion about that?
Yeah, I think it's great. And one of the reasons I think it's great is because when you actually look at it in industry, that's basically what we're doing, right? We're taking, you know, some really sharp software engineers, we're combining them with a team of industrial engineers and you know, manufacturing engineering and mechanical, and that's what ends up being our integrated product teams that are developing, say, an automation cell or looking at you know, connected equipment. So yeah, I think those interdisciplinary team, either projects or actual curriculums where you've got, you know, multiple colleges or within the colleges and the university working together, I think it's excellent.
So we will reach out to you and to start some project. Thank you, Kelly.
All right. Thanks, GP.